Alright, hey, what's up? It's Matt. Just an update on my Threadripper system here. Let's see. So, I'm running Pop! OS, 6.12 kernel. Like I mentioned, Pop! OS, so the window manager is Mutter. It's a Threadripper system, 3960. It's got 48 cores, and it's running a 4060 NVIDIA, and as you can see, I've got like a lovely array of CPUs here. It's got 48 threads. Usage is always essentially 0. It's a great system. I've got a bunch of storage arrays. I've got some RAID arrays. I've got this one really slick all-in-one card that is a RAID 5 array of 4 different 2 terabyte drives. So it works out to about 6 terabytes of storage in RAID 5, so there's redundancy. Got my home, my boot. I don't know what that is, actually. And then a nice juicy 14 terabyte hard disk. But my seen container D run across the background there. My principal software project is a project called kmerdb. It's a kmer counter. I did a Rust port of it, and then was working on a click refactor for at some point. This spun out of a project called kmerd.js that I was working on in 2017, 2018, 2019 era. That's probably the biggest things to mention. And then I've got this Kubeflow thing that I'm going to demo here in a second. Show you what's not working at the moment. So let me start my Minikube, which is a compliant Kubernetes minimal install. Just booting up Minikube. Put some new thingy things here and run my istio and dex scripts. Use dex. Alright, that's running, and then same thing. Hold on. Alright, so now istio is up and running. Okay, so this should work. There we go. This is exactly what I want. Nope. Connection refused. Lost connection to pod. Hold on. Let me... There we go. So... And... Great. Forgot an R. There we go. So this is the Kubeflow dashboard. I've got some pipelines. I've got some example stuff. And then I've got my glorious, very basic RNA-seq pipeline. It's got some linear steps and some fastqc control steps. These all take fastq files as input, feeds it to bowtie, and then does a bunch of RNA-seq alignment post-processing stuff. I'm not going to go into the Docker images at this point. And so at this point, it's kind of having some issues. It's a locked in a pending state because I mount a persistent volume claim, and that's not made available directly to the pods. So that's kind of where I wanted to leave it. It is a cool RNA-seq pipeline. It's more or less the same one that I used in grad school for my whatever it's called, my thesis project. And that's more or less it. Maybe the only other thing that I'll go to is go to a KDB. Alright, so this is a ugly directory. Maybe I'll go to the GitHub page. GitHub. Alright, let's go to... Well, first maybe I'll show off my blog a little bit. So here's my blog website. You can see it's got a lovely, accurate picture of myself. Some self-descriptive type stuff, mention about the consulting stuff, and then some cool blog posts. I'm pretty proud of this one. It took me probably less than 15 hours to do. It's about an hour read. It mentions it's about 9,526 words. It's got a nice table of contents on the left-hand side, and if you scroll through it, some of it opens up in different sections. This is a little bit of civil rights history, which is important in today's era. It's got a section on Brown v. Board of Education. Talks about the race question, which was central in the case of Oliver Brown versus Topeka Board of Education, where the NAACP and Thurgood took it up. It's got an electoral map showing segregation, educational segregation prior to Brown. And it's got some Plessy v. Ferguson stuff, Civil Rights Act. Nice little thing from Wikipedia.
My fellow Americans, I'm about to sign into law the Civil Rights Act of 1964. I want to take this occasion to talk to you about what that law means to every American. 188 years ago this week, a small band of valiant men began a long struggle for freedom. They pledged their lives, their fortunes, and their sacred honor, not only to found a nation, but to forge an ideal of freedom, not only for political independence, but for personal liberty.
Okay, so the last thing that I'll mention is the features and odds ratio calculation, particularly the odds ratio of being both homeless and black compared to homeless and non-black. So for those of you that don't know, an odds ratio and similarly a risk ratio is basically you're comparing how likely something is versus another, and the thing that you're interested in is on the top of the ratio, and the thing on the bottom that you're comparing it to is on the bottom of the ratio. So in this case, the odds of being homeless and black is on the top, and then the odds of being homeless and non-black is on the bottom of the ratio. If an odds ratio is less than 1, it suggests that the factor of the numerator, black and homeless, is less likely than the factor making the denominator, non-black and homeless. However, if it's greater than 1, it suggests that people that are African American are at greater risk of homelessness than compared to all non-black persons that are also homeless, right? So these data are based on U.S. Census Bureau population estimates from July 1st, 2023. Also, Department of Housing and Urban Development, HUD statistics from 2023 in the same quarter of the year. And the report's called the Annual Homelessness Assessment Report to Congress. Stats taken from page 24 and from the U.S. session. I also mentioned that the full Python session that I used to calculate the odds ratio is kind of given at the bottom. It looks really long and complicated for something that's essentially not complicated. I do a bunch of other different. The worst risk ratio, or the worst odds ratio, was looking at people that are Pacific Islander and homeless over white and homeless, and that ratio is close to 7. So if you are a Pacific Islander person, you have almost a 7 times greater risk. It's not a risk ratio, but you have 7 times greater odds of being homeless than compared to being white and being homeless. So if you are a homeless person, you are 7 times more likely to be Pacific Islander than you are white. And then there's all these other, I do it for Latino, I do it for black versus white versus black, white and homeless versus all homelessness. And then I mentioned that it's similar to the risk ratio, which is much easier to calculate, but the odds ratio is a little bit more specific. 32.2% of the homeless are African American. 13% of the American population is African American. So on face value, dividing 32.2 by 13% is over 2. But when you calculate, so the risk ratio is closer to 2 for being, you're more likely to be African American if you're homeless than white and homeless. This is the odds ratio, odds black and homeless. Anyway, the way to reproduce it, including some commentation, like some comments, and I included all my errors so that you can see, like, I'm not calculating this perfectly. I'm basing it on census data and HUD data, but I don't do everything right the first time through, and then I, comment, this is what I was thinking at this point. Let me correct this, blah, blah, blah. Make sure that it's from the right page or maybe the right year. So calculate in Python 3.12, blah, blah, blah. And it shows my thought process. So that's my odds ratio calculation. There's a nice little primer on the history of civil rights history, 1950 and 1970. And a discussion of specific American civil rights. What we refer to as civil rights in America is really a collection of ingrained civil rights, like the right to freedom of speech, freedom for religion, freedom to bear arms, all those different, intrinsic civil rights in the United States. But in addition to that, what people often demonize as the welfare state really is a selection of different services that Americans are entitled to, namely services that protect public health, social welfare, well-being, and civil rights, which include stuff like freedom from employment discrimination. This stuff includes stuff like the public health services, which includes the NIH, the CDC, the Substance Abuse and Mental Health Services Administration, and the Food and Drug Administration. All of these are essential services for Americans. If you know anyone that goes to a public school, 60% of American children get low-cost school lunches. It doesn't mean that they get free lunches. 60% of American children are receiving food subsidies through the National School Lunch Program. 60%. That's a large amount of American children. It's millions of children a year. 30 million children per year, with a cost of about $17.2 billion. In comparison, big tech, big pharma, and Wall Street institutions dodge around $606 billion. That's how much they're not paying back to taxpayers and paying back to Congress. That's how much they dodge a year, $606 billion versus $17.2 billion. So whenever someone says, we don't need a free school lunch program, statistically we do. And second of all, these assholes are dodging almost $750 billion. They're dodging the taxes. The DoD has a budget of almost $1 trillion in 2023. The DoD just failed its 7th audit. The NFL has a budget of about $20.2 billion. Sorry, has a revenue stream of $20.2 billion. So I think that in a certain way, Americans can definitely afford something like the National School Lunch Program, and it's historically been a very important thing. Then we've got FEMA, the NSF. There's all these different specific chapters in the U.S. Code 42, which is the centerpiece of civil rights. And these are things that are at risk of being disassembled by the current administration. There's some retrospectives and a brief discussion on women's rights, racial equality and equity, in this graphic that I was referring to earlier. So this is a kind of a cool, it's a nice overview thing. I've got some Python stuff in here, a description of my current system, which is probably relevant to this video. I tend to install Python from source, system-wide, and then I use pyenv and pipenv to manage Python from that point on. Pipenv is PYPA, so the Python package authority is PYPA, and pipenv is a tool that is PYPA, developed by PYPA, and it integrates with pyenv. Pyenv is a third-party tool. I forget who developed it. I've been using it for about 10 years now, almost 10 years. So this is how I manage both my Anaconda environments when I need them for installation and management of software packages for bioinformatics, as well as just, kind of like a PYPA, PYPI centric Python environment. So once I install from source system-wide, I just glue into a specific number and then use pipenv, and then pipenv will create virtual environments and launch a shell and maintain those packages, and I use that for project-specific stuff, which I'll demonstrate in a minute with the kmerdb. RStudio, I usually go to pause it and grab their deb package. Other things of note is I occasionally use Ruby for Jekyll blogging, including this blog, including my snazzy blog with all these different about sections and blog section. It's got a nice history thing, and then other BS. Git, obviously. Git mode is this convenient kind of like thingy thing. Hold on. You can see down here, I've got like this little status line. My machine is called Endurance. It's named after the fictional ship in the movie Interstellar. And this is my fourth iteration. This is kind of like, when I use my Endurance name, it's kind of like, this is my least common denominator system. It's not like a custom, it's not like an Arch distribution or Gen 2 or anything like that. So I'm using Pop! OS, so Endurance is currently tied to Pop! OS. It's kind of like my generic system. Otherwise, I use the the host name Argo, because Argo is one of those, what is it, the hero Jason, I think, in Greek mythology, and his crew ride on the ship Argo. So that's my kind of logic behind it. If I, for instance, let me modify the README for a second. So I'll echo foo into README. You can see there's nothing on the status line. It just says on the main branch with the Git version control system. Now I've got a little red plus sign right here, which tells me that and if I do this, git add README herder. There we go. Now it shows up as a little green asterisk. So, anyway, it's kind of like a quick little thing that tells me if I have unstaged changes or or stuff committed to the index but not checked in to a commit. What was I saying? Oh yeah, pipenv. So I use Ruby RVM. Use this little script called git mode, which I pulled down from someone on GitHub at some point. It's just like a little shell, very lightweight shell configuration. It's handy. Sometimes I use Twig. Most of the time I don't. Use GPG2 and SSH, OpenSSH. My primary productivity system consists of Emacs, plain and simple. So I use org mode a lot. Let me see if I can demo that real quick. Let me go to my to-do. Bring it back. Okay, so still in the kmerdb repository, I've got a little to-do file. So everything is... So it's not really showing all the stuff on the line, but here we go. So this is a collapsible organizational system. You can cycle. I can cycle. So for example, I've got a subheader named dates and collapse it and then expand everything. So the last thing I was working on was working on some NetworkX stuff for a De Bruin graph stuff for a De Bruin graph related assembly quote unquote solver for pathfinding algorithm for the kmerdb suite. So let's go ahead and launch the pipenv shell. I might have blown it away recently. Yep. Nope. Hold on. Pipenv. There we go. So I had to spin it up from source. All right. Pip install. And so it'll get my pyproject.toml and load all the dependencies. Make sure everything's installed, yada, yada, yada. You can see I've got some BioPython, some Python. I used to use JSON schema. I'd love to convert it to, Pydantic or data classes, but I don't really care that much. NetworkX, NumPy, Pandas. PyYAML, I love PyYAML. I love YAML. Toml, not my favorite. So it's downloading, installing some stuff. And soon I'll have my shell with my kmerdb program installed. There we go. So I can do kmerdb help. And it prints out some juicy citation information. And there's a bunch of commands. The primary ones are profile and graph. I've got some code on frequency stuff, code on usage bias that's kind of wonky. This is new. This took like, a month to do. Not a whole lot of coding. I've got a minimizers thing that I'm hopefully going to feed into a Smith-Waterman alignment kind of thing. Lastly, I've got some normalization stuff that goes along with my, just collating kmer count vectors. That usually feeds into the distance function, which can aggregate kmer count. Sorry, that's absolutely wrong. Yeah, this does not show the metadata. This is, I need to fix my help. But if I do distance, for example, this is correct. All of the individual ones are correct. It's just this, top level thing that's a little goofed at the moment. So this is the distance function. You pass in a bunch of either KDB files or a tab separated value matrix data, account matrix typically. And then you can do Chebyshev, squared Euclidean. Pearson is a custom distance function that I wrote. It's also got correlation distance, which I think is SciPy. Correlation distance, which is SciPy. Pearson is a bona fide Python implementation of the Pearson correlation coefficient. So there's different distances. This will create a distance matrix. So typically you collate several profiles into a count matrix, feed the count matrix into the distance command to calculate the inter profile distances, and then produce a symmetrical distance matrix. It might be triangular, I don't remember. Then you can feed that into k-means or hierarchical clustering once you have a distance matrix. And I think k-means uses either SciPy or BioPython. You can see this says hierarchical clustering. Hierarchical clustering is always BioPython. K-means, I think, has SciPy and BioPython options. That's it. That's probably it on that. Maybe one more thing. Let me test some test data sets. I'll do test CAC because that was the last thing I was working on, I think. All right, so here is a kmerdb file. It's got two different indexes. One is an absolute index that is lexically ordered. It's just an integer. And then we've got the actual kmer ID, which is also an integer, and you can see they're in lockstep by default. Then you've got a count and a frequency associated with the that kmer. So that's how many times that kmer was counted. It's not. Yeah. So here's some. This one was observed 212 times, but in the total genome, or in the total kmer count, this was that, a very small number. That number of occurrences, or that frequency of occurrences. So let's go ahead and do this. Let's do 30. So this is the format. Currently this is showing 0.94. I think I'm on 0.95. The choice of K was 8. There were 4,132,000 kmers counted. Of those, there's also a non-canonical. So these are canonical and unique kmers. There were 167 nullimers that were canonical and unique nullimers, obviously. I think nullimers by definition means unique, but I just put that to be extra clear with people. If you do this with non-canonical kmers, sorry, this is the canonical, 32,000 canonical kmers, 8mers. If you do this as non-canonical, then it's like 60-something thousand canonical unique non-canonical unique kmers. Sorry. And then you've got your read length, the PSOL chromosome and CSC butylicum ATCC 824 is 192,000 base pairs. The maximum read length, the CAC genome was 3,940,000. The 0th kmer, which I think corresponds to AAA, was observed 1,135 times. Also, it might be worth showing if I import, let me see, from kmerdb, import kmer. If I have a string, ATCAG, let's call it test kmer. Test kmer equals ATCG. And then I want to calculate the 8mer index of it. Hold on. Let me do this as shred. Sorry. Let me start there. Test camera. 8. Wow. Okay. Yeah. So the 8mer. This is the ID of that 8mer. Let's do it as 6. Okay. So here we've got a 6mer ID as an integer. That is 915. And let's go ahead and map this. List map. List of map of lambda. This is so hard to do with one hand. I'm just doing this because lambda, let's call it k. Let's map it to kmer.id to kmer. And then we'll do k. And then we'll say 6 because I shredded the untitled sequence in intervals of 6 and I got 3 IDs. So this was the sequence, ATCG, ATGC. So I think this is it. Let's try this. Okay, and then this should be the 0th. There we go. So we got ATGC, AT, that's a 6mer. This is the next sequential. Oh, these are canonicalized. Alright, let's try that one more time. And actually, I'm going to do the help on this. No. Help. Okay, so here's my function. It's got documentation. So it takes either a string or a seek record object. It's got replaced with none. That's a goofy thing I don't want to go into. Canonicalize. Alright, so that's what we want. The canonicalized parameter canonicalized the kmer IDs to be strand agnostic. We don't want that. Alright, so let's do the same thing, but canonicalize equals false. We want these to be the kmers that we used in the original sequence, which was ATGC, ATGC. Alright? There we go. So you can see this is the second kmer in this sequence. Right up here. So the second kmer is TGCATG. And we've got them in order. And at the second position, third position, so on and so forth. So this produced shredding an 8mer sequence into 6mer sequences gives you k minus n plus, or k minus n minus k plus 1. So n is 8 minus k is 6 plus, that gives you 2 plus 1 is 3. So there are 3 6mers that come out of that sequence. For the sake of argument, this is a position, I believe, that's used at some, used at no points actually, but can be useful. And then because it wasn't given an ID and it wasn't a BioPython seek record object, it's just given untitled sequence as part of the output from the shred function. That's the one we saw the documentation. So also, if I have test kmer, let's do one last thing. kmer.kmer2id from test kmer. It's obviously an 8mer, so it converts that to an 8mer ID of 14649. And then if I do kmer.id to kmer, and then I give it 14649, and then I say this was an 8mer, because otherwise it's ambiguous. It depends entirely on what the choice of k is. Then it spits out the exact same sequence. So it's idempotent. I think that's what's called it, idempotent. So that's that. Yeah. So as you can see, I use org mode for a lot of notes. I've determined that the blah 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 path for unit collapse is indeed blah. That's actually how I write, believe it or not. I'm using a so I was working on MEC1, which is a human and mouse sequence. It's a map kinase pathway. ERK, whatever it is, map ERK. As a simple example, to try and rebuild an Eulerian path from FASTQ data that were simulated via the ART Illumina read sequencer on the MEC1 transcript, one of the MEC1 transcripts. It didn't work the way that I hoped to, and when you use NetworkX, the helper for the NetworkX functionality in the graph component of kmerdb, it doesn't reproduce the Eulerian path through the k+1 mer de Broglie graph of the MEC1 transcript, which was a real bummer. So I've experimented with this non-canonicalization to maybe help potentially with that, but that also made it difficult, so I had to back add canonicalization, which was easy. Orgrim UI, this is something that would be just eye candy for people who don't know org mode. Let's see. I think it's meta X and then orgrim UI. Orgrim. Let's try. There's a lot of orgrim functions, which I don't even think orgrim is that great. All right, it's cycling. That's what it is. Orgrim UI. Orgrim. What is going on? Dailies. That's so weird. Huh. Maybe I have to go to the directory. That's probably what it is. Rome. Open that. Work Rome. DB sync. It's not. I know. I don't want that. I don't know if that's it. Huh. This is so weird. Hold on. List packages. Orgrim UI. Orgrim UI. Oh, it's available, but it's not installed. Alright. Okay. Let's go back. Orgs Rome. Go to vector org Rome. UI mode. There it is. Here we go. Alright, here's my org Rome. And it's not working at all. That's a bummer. How did that not work? Callback. SQLite Open v2. Okay, well this was supposed to show a really snazzy org Rome visualization. It's a bummer that I don't have it because I've got a bunch of stuff in org Rome. Alright, let's go back to the tour. Yeah, that's more or less it. I use org agenda for capture mode. I got a pretty boring basic system setup, and I'm happy with that. I do use various crates. I use Z occasionally when I want to use my OpenAI credits, probably Numix for icons, other boring stuff. And got some Ardor, some Dotes, Flameshot, IGVG parted. I don't use Postman at all. I don't know why that's in there. It's probably bloatware. And don't use Telegram. I don't know why that's in there. Civ 5, Redshift. That's kind of it. Oh. If anyone has any information about this, I'd love some help with it. So I run MPD, and then RMPC, I think. Here we go. Generic error, this is file. Oh yeah, this is great. Love it. So it's displaying all of my album art, RMPC, the music player, Rust. Oh, there it is. Cool. My music's working. My heavy hand is full of debris. Sometimes I wish the city would sink in the sea. 'Cause even if you find the love, it's fake. And everything I wanna touch would break. So it's displaying some of my album art in very reduced bitmap kind of subsampled stuff. That's kind of a bummer. Let me pause. There we go. So that's more or less the tour of the website, kmerdb updates, the Kubeflow situation with the persistent volume claim not being mapped correctly. But you saw probably how quick it was to set up my entire Minikube setup from my configured Kubernetes thing. And yeah, I've got it installed with some stuff about Minikube and Docker and all that. Using Kubeflow manifests. Using this one, actually, think that one. Not using OAuth 2. Got some pipeline components and other stuff, YAML files, and then only a handful of scripts. And then Docker files. And that's it. That's my entire Kubeflow setup. Something that, a little shell script to get Helm, get customize, to edit my DEX configuration, make sure that localhost is allowed, and for whatever reason that's persisting, even when I shut down Minikube. This is something, it uses a Helm chart to get the NFS subdir external provisioner, which is when I'm not using other storage provisioners, cert manager, istio, knative serving, and then the kubeflow manifest. Patching min.io artifacts, which is useful, and then stuff for just launching the DEX server in istio. That's it. Otherwise, I've got a really nice working dashboard interface for running pipelines, loading pipelines via YAML, showing the organization or the DAG of the it's got the full, it also has the full YAML. This is the generic Kubeflow pipelines UI dashboard, and then lists of your runs with the nice friendly status. I'd love to turn this into IP at some point. Also, a shameless plug for NordVPN. That's probably it. Probably the only thing else worth serving. And RMPC for the win, because Spotify is blowing right now. These price increases. So annoying. Yeah, that's it. Friendly looking workspace. Got my transparency coolness on running Wayland, and that's it for me. Thanks for watching. downvote, report, and unsubscribe.